So I'm going to start by showing you a quick recap of that starter, covering just the basics, showing you a quick table that's useful. Not going to spend loads of time on that though. So here's your reminder. Number out in front of our equation, as we change that. Key thing I wanted you to spot, you're stretching in the y direction. So if you go from 1 to 2, our peaks, our top points, our maximums in the curve move to 2 or 3 or 4, depending on how big we make it. The second one, changing b, that's the number that comes in front of x. Changing that value for b from 1 to 2 actually means that the curve repeats more often. So you get 2 repetitions of the cost curve in this case. Between 0 and 360, you now get 2 repetitions of the cost curve rather than just 1. That's super important because it means that everything's happening twice. Sometimes you'll see me that call a squash by 2 in the x direction because we're squashing in more curves. So I will use that terminology, squash in the x direction, to describe that. With the c, that's what's added on to our angle. Well, this is important as we move this up. So here we're adding 90 onto our angle. You'll actually spot our graph has gone to the left. Now that's a bit counterintuitive, but it is something you need to remember. If you add something onto the angle here, you are moving your graph left. If you take something off the angle, you're moving your graph right. So that's a super important one to know. Final one that we have to play with is just adding or taking away something from the end of our equation. Adding on the end moves our graph up, and taking away moves our graph down. So that's just a quick summary of what I hope you reminded yourself of. It matches everything that we have done with graph transformations earlier in the year, but here we're just applying it to trig functions specifically. So hopefully you can see there we've got our different things that are happening, like putting the a at the front or the b in front of the x, or adding the c or adding the d at the very end, and I've written down what each one of those does. Particularly remind yourself, adding something to the angle moves us left, taking something away from our angle moves us right. That's the one that's a bit counterintuitive. Now, what are we actually transforming? Well, we are transforming graphs, but the questions that we're going to hone in on, we're not really worried about the whole graph, we're worried about key points. So here I've kind of summarized what the graph shows us, and here are our key points. So the top line of our table here shows us that sine x crosses the x-axis at 0, 180, 360. It's got a maximum point at 90, and that maximum point is at a height of 1. So that's that first up on the sine graph, and then it goes down. The dip in the curve on the sine graph goes down at 270 degrees. It goes down to -1. So I'm just reminding myself of these key values. Each time we start a question, we're going to want to know those key values. So here are 3 questions I'm going to show you how I'm going to answer. So the first one, I want to know the maximums and the minimums of y equals 3 cos of x plus 20. And I want to know that between 0 and 360. Obviously there are loads of points. Every time the sine graph or the cos graph does a wiggle, you get a maximum and a minimum. So that's why we've got that range there. We only want the ones between 0 and 360. So how I'd tackle this? Well, I would write down, for starters, that the cos graph, just the basic plain cos graph, has a maximum at 0, 1. So let's see that just quickly. So there's our cos graph as a maximum at 0, 1 here, a minimum at 180 -1, and then another maximum along here at 0, 360 degrees. So I'm just recording that information. 361 is a maximum, 0, 1 is a maximum, and 180 -1 is a minimum. Now what happens if I put a 3 out the front? So I've now got 3 cos of x. I'm not worrying about the plus 20 yet, but if I do 3 cos x, well, that's changing the number out the front to be a 3. So remember, that's stretching it in the y direction. So now my maximums are at 0, 3, 363, and 180 minus 3. So that's what happens if I put a 3 out the front. I'm stretching each of my y values out by 3. Now let's worry about that plus 20. Well, if I do that plus 20, I am shifting my graph, and remember, as I add 20, you'll spot that graph has moved to the left. So my maximum is now at minus 23. My minimum here has moved to 160. Yep, there it is, better. 160 minus 3, and my other maximum here is at 340 plus 3. So the graph's just there to help us see it. So that changes the x value by taking 20 off whatever the x value was. So 0 goes to minus 20, 360 goes to 340, 180 goes to 160. And these would be my final values, but I was only interested in the range from 0 is less than x is less than 360. So this first value, which has an x value of minus 20, is no good. So we score that one out, and the maximum and the minimum are there. Now I'm not going to go into them as much detail with this one, but I'm going to take the same format. So cos x has a maximum at 0, 1 and 361 and a minimum at 180 at minus 1. First thing I'm going to do is I'm going to add that 6 on. Now remember that shifts our y values up by 6. So those points, instead of 0, 1 become 0, 7, 361 becomes 367, and the last one, the minimum, instead of being 180 minus 1, moves up to 185. And then the second transformation, which is to take 50 off the angle, remember that's moving everything to the right by 50, so I am adding 50 onto each of the angles that I had before. Finally, let's just check the range. I was only allowing x's between 0 and 360. Well, 50 is fine, 410 is not, 230 is fine. So we lose the 410 one because it's not in our range. Okay, last example. Just one with sine, just to show you it. And also I have put this one in radians, just to show you that as well. So here we've got sine x, 90 degrees or pi on 2 radians is where our maximum is on the sine graph. 3 pi on 2 or 270 degrees is where our minimum is, and there obviously the value is 1 and minus 1. If we stretch in the y direction by 5, by doing 5 sine x, that changes our y values to from 1 to 5 and minus 1 to minus 5. The other transformation is to take 2 away at the end. Now remember that just moves the graph down by 2. So we're changing y again, so we're taking 2 off our y values. So taking 2 off each of our y values, and there's our maximum and there's our minimum, and we're sorted. So hopefully that shows you how we're converting and moving around sine and cosine graphs with this. Now we're going to apply that to some wave equation stuff and see how they move around as well. So hopefully that just gives you a bit of a context to build on with the second video for this lesson.